Hello friends, welcome to today's operating system class, and in today's class we will learn something about system calls, and this is one of the important topic from first unit. And in this lesson we will learn what is system call, user mode and kernel mode, example of how system calls used by the operating system, and next system call interfaces and the methods used to pass parameters to the operating system. Okay, these are the topics we will discuss in today's lesson. First, let us see what is system call. System call provide an interface between the user and operating system to provide services to the user by accessing the resources, system resources. Okay, here this is the user tries to access the system resources, that is computer system resources. It may be either hardware resource or software resources. That will be possible only by means of system call. System calls. Okay, and these system calls are available as routines. This is nothing but a program. This will be written in either C language or C++ language. Sometimes it may be in assembly language also. To access the lower level information or other system resources. For example, a simple command, to execute a simple command, the operating system will execute thousands of system calls per second. Okay, for executing a very simple command, it requires more number of system calls to execute to complete that particular command. To learn system call, it is important to understand which is kernel mode and which is user mode. If the CPU is in kernel mode, suppose if the CPU is in kernel mode, then it can directly access memory address and hardware resources, because the kernel mode is very privileged and powerful. Very powerful mode, because from the kernel mode we can easily access all the hardware resources. If the program crashed in the kernel mode, then the entire system will be halted, because this is a very sensitive one, right? But if the CPU is in user mode, here the program does not directly access to the memory and the hardware resources. Okay, from user mode we cannot access all the hardware resources directly. Through this kernel only the CPU can access the resources. Okay, what is the advantage of user mode? If any program crashes in the user mode, it will not affect the entire system, only the particular program will get crashed. Okay, hence the system is very much safe in the user mode. So most of the programs are run only in the user mode. Here let us assume a program which will run in the user mode requests resources or any hardware, then it must ask the kernel. Okay, because only kernel can provide the resources to the user. Okay, for that this will use the system call. Okay, through the system call only we can access the resources which is available in the kernel. Okay, for that the program makes a system call. Then the mode is switched from user mode to kernel mode. Okay, initially the program is running in the user mode, then that will switch to kernel mode, because from the kernel mode only we can access the resources, either it may be RAM or any other hardware resources. For this purpose we can use this context switch. The purpose of context switch is to transfer the mode either from user mode to kernel mode or kernel mode to user mode. Then the kernel will provide the resources which the program requested. Okay, after the request completed, then another context switch will be there to change the kernel mode to user mode. Let us see one example for system calls. The example is read a data from one file and copy them to another file. That is, we are going to copy the content of one file and to another file. So this is first one is source file and second one is destination file. So to copy this content of source file to destination file, let us see how many system calls will be used by the operating system. What is our command? Copy file 1 and file 2. File 1 is input file, that is the source file, and file 2 is output file, that is the destination file. Okay, here the system call used for this is open the input file. First one, what we have to see, first this file should be opened. Okay, and second one, we have to create the output file. Okay, create the output file. Which is output file? File 2 is our output file. Okay, to open an input file, the file should be already exist. The file 1, that is file 1 should be already exist, then only we can open that file. And to create an output file, the output file should not be exist already. Okay, that should be a new file, then only we can create the output file. So these are the condition. If it is not satisfied, then error condition will be there, then we can print the message about the system call, right? So what are the system calls we have used here? Open, create and error message for that print and abort. After that is after successfully open this input file and after successfully creating this output file, then read the input file and write the content to the output file. Okay, so this procedure will be continued until end of first file will reach, end of file 1 will reach. Okay, once this completed, then we have to close the input file and output file. After that, terminate the system with successfully, that is success message will be given to the user. Okay, so these are all system calls which will be executed by the operating system to execute simply this copy command. Okay, from this diagram we can see the system call sequence. First, acquire the input file name from the existing file list, right? Write prompt to the screen to get the input file, right? And accept the input, that is through keyboard we can access the input file. And second one, acquire the output file name from the write prompt to screen, accept the input, that is we will get the output file as the input here. Okay, this is the first step and this is the second step. And third step, we need to open the input file. Okay, open the, which is our input file? File 1 is our input file. Okay, if the file does not exist, then we have to abort this command. Copy command will be aborted. And fourth step, otherwise we have to create the output file. The output file is already exist, again we have to abort. Okay, and the loop will be continued. Read data from input file and write data to the output file until read fails or it reach end of file 1. Okay, so once it completed, then close this output file and input file and give the message that write completion message to the screen and terminate the program normally, that is successfully. So these are the sequence of system calls to execute which one? Read the data from one file to another file. And next let us see the system call interfaces. It is used to link the system calls and which are available in the operating system. And the programming languages, it may be any programming language, either C or C++, which provides the runtime support system. Runtime support system is a set of built-in library functions which included in the with the compiler. So along with the compiler we are having a library functions that will provide the system call interfaces, and all the system call are having a unique ID, that is unique number. By using this unique number, the system call interface maintains the table indexed according to the system call's unique number. Okay, all the system calls will be stored in a table indexed with the system call number. Okay, and the system call interface then invokes the intended system call in the operating system kernel. Okay, and returns the status of system call and returns any value. Let us see one example for this user call interfaces. Here this is our user application that will give request with the system call named open. Okay, as per our example, copy file 1 and file 2. So we need to copy the content of file 1 to file 2. Hence we need to open this file 1. So open system call will given to the system call interface, and this is worked under the user mode. Okay, after that the context switch will switch the user mode to kernel mode, and inside the kernel mode we are having system call table. This is system call table. Here all the system calls will be stored along with the number, unique number. This is the unique number. Okay, so under this unique number the system call open will be stored. This particular function is being stored in this place, right? So once the open function got executed, then the corresponding value will be returned back to the system call interface, after that to the user application. To execute the system call, we need to pass the parameters to the operating system. Here we can have three methods. The first one is very simplest method. Here the parameters will be stored in registers itself, directly in registers. And in some cases, if we are having more number of parameters, then registers are not sufficient. Hence we will store the parameters to the table in a memory, and the address of this table will be stored in the register. So the parameter register contains the address of table, that is the parameter table. And the third method is stack method. Here we are having very large number of parameters, hence the parameters can be pushed into stack by the program and popped off the stack by the operating system. Okay, these are three different methods of passing parameters to the operating system. So in this diagram we are having the user program and the register and the operating system. Okay, here the user program, the parameters will be stored in a table, and the address of this particular table is the x. X is nothing but the address of parameter table, and this address will be stored in the register. Okay, that will be used in the operating system. Then all the data which are stored in this table will be accessed by the operating system, that is user parameter from table x. X is nothing but the address of parameter table. Up to this we have the system calls from the first unit, operating systems. Okay, under this topic we have seen up to this what is system call, system calls for user mode and kernel mode, and example of how the system calls used by the operating system and system call interfaces. After that we have seen the three methods used to pass parameters to the operating system, and in the next class we will see the types of system call. Thank you.